Hello world, let's make a video game, retro style. I don't mean a retro styled video game, I mean let's make a game in the spirit of how they were made back in the 80s and early 90s. Just me, my Agon Light and a C compiler. No fancy game engines, just my code talking directly to the machine and its operating system. I don't quite know what I'm doing and I don't really have any plans. I don't think this matters though, because looking at the shareware games I used to play back on my old computers certainly didn't stop people back then. So welcome to a video series that I'm calling Game Dev the Hard Way, and I'm bringing you along for the ride, so let's go. Before diving straight into writing code, let's set the scene. I'm not making a tutorial series here, I want to tell a bit of a story. There's plenty of videos on the internet where people describe how they're coding a game, and all they do is they take you through it line by line. I want to make it a bit more interesting. So we're doing this as if we're coming from the perspective of someone like me who wants to make a game, but back in the 80s, that they want to get other people to play. Back then we didn't call these games retro games. That term didn't exist because obviously retro hadn't yet been invented. Today, the lumpy pixels and bleepy sound effects that you see in retro style games is a stylistic choice. It's people choosing it as an art form. Back then, it was all the hardware could do. We also didn't have the internet, so there wasn't a massive electronic resource to tap into for knowledge. If you didn't know something, you either had to work it out yourself or find a book. Equally, there wasn't this massive free distribution network that we could just push our games into and then tweet and tell people to play it. Instead, the main way people like me or anyone else learned anything or found new software was either through magazines or online services. These magazines anyway, and bulletin boards, and the odd mail order company were how we got software. But it was also how software was distributed. This didn't earn you any money though. It's not like the magazines or bulletin boards paid you for having games. And this spawned a whole new system called shareware. The idea of shareware was to give away a demo of your game for free and then try to convince players to send you money in exchange for the full game. People would put their home addresses in their games and ask people to literally send them money through the mail. Like, please put £5 in an envelope and post it here. Sounds completely bonkers now. But in the UK especially, it was a legitimate way of making and releasing games. Now these magazines and mail order libraries were my main source of software. I was a kid, I didn't have a job. My parents weren't going to spend 20 quid on some game I might get bored of after an hour. It's a good job they don't see my Steam library at the moment, which is full of all that kind of stuff. Now this is where I found some of the most fun and imaginative games that I've ever played. Whether it was someone's reinterpretation of an arcade game on my Spectrum, or some bizarre surreal trip through Jeff Minter's mind on my ST, I found a lot of entertainment. Shareware games were different to commercial games. The British ones especially were just plain weird. Don't know what it is about sticking us lot by a computer by ourselves, but there were no limits, there was no risk, no sales target to hit. Just people made stuff. This style of game is what I want to make. Not a recreation of someone else's game, but the kind of game that comes from a single person doing everything by themselves and trying not to take years making it. This is not going to be my most fantastic work that people will forever remember me by. I want to make a game, you know. Maybe someone will like it. If not, whatever, I don't care. I'll make more and learn from the experience. I need to come up with what they call in the industry though, a game concept. Let's go do what people did in the early days and nick some ideas. Sorry, let's get inspiration. So I'd best go fire up some emulators. I'll see you in a minute. While I waffle on, let's look at some of the shareware games that I remember. Some are classics from that platform and time, others simply stuck in my brain, probably because I had nothing else to do after reading the magazine they were stuck to. The games you're looking at have a few common themes. They're all quite hard to play, but they're also quite simple to understand. Because nobody reads instructions, so figuring out the game as you play it is what you do. Some of these games have really ropey controls though. Making the game fun to control is really important. I like the arena shooter style of games. Llamatron kept me occupied for hours. This one is called Robots, and it's got an interesting art style, and I quite like the basic premise. I don't have a complete design in my head yet, but I think I have a starting point. I'm not trying too hard to have a solid plan right now. I don't know what I'm doing, so I can't be expected to make any sensible decisions beforehand. I do know what I don't want to make though. I don't want to make outright clones of existing games. So no Pac-Man, nothing Mario shaped, or anything else that we've seen thousands of times, so no Tetris and all that kind of stuff. What I'm going to aim for is some sort of top-down arena shooter game, a bit Llamatronic, but maybe with the idea of opening an exit to leave the level or something. It's not an amazingly earth-shattering original concept. There's a fun game called Crystal Quest that came from the Mac that works like this. I don't know what the theme of the game will be, or what the player will even look like. But so far, I've got the following vague ideas. Top-down arena shooter. Avoid enemies, do something to open an exit, some sort of probable sci-fi theme. It's got to be quite hard to play, but I want the enemies to do more than just home in on you mindlessly. I've added that last one because a common strategy in most arena shooters is to simply circle the enemies, group them into a lump, and then go and shoot at them as they mindlessly just walk together. You see, I want there to be several loops of gameplay beyond repeatedly shooting moving objects on the screen. Maybe being able to push items around to block or trap enemies, or lure them onto traps would be interesting. The game world I think needs to be interactive as well. The title of this series is Game Dev the Hard Way. I'm doing this on my Linux machine for the Agon Light. The hardware restrictions are what make this interesting to me. I could just load up a modern game engine, but I like the challenge of writing software for really limited systems. Also, I've got the beginnings of a tidy little game engine for the Agon, and it now needs using for real. There's only so far I can get with learning the hardware in disconnected separate pieces. The first step is to download a copy of my Agon game engine thing from my GitHub repo. This series isn't a tutorial, but if you want to make your own games for the Agon, you can grab a copy too. As I add new functionality making this game, I'll update it as well. I don't particularly want to give the source of the game away, because it's going to be a complete mess whilst I figure out what I'm doing. So I'm going to stick this on my own private Git repo out the way. If I've got everything set up correctly, I should just be able to build and run this code in an emulator. I will at various points run the game on proper hardware, but development goes much quicker if I can just test it in an emulator. Okay, I've seen enough game dev tutorials and read enough posts from people who write about making games to figure out the first thing is to make a working prototype. There's literally no point spending hours of my life trying to make a game if the basic idea is a bit crap. So let's get a rudimentary arena shooter working. To do that, I'm going to need the arena, which is now just going to be the whole screen. I'm going to need a player that I can move around the screen. At least 2 different enemy types that you can shoot at, which means I need a way for the player to shoot and some collision detection. Since I don't know what the game will look like yet, I'm not even going to waste any time finding graphics. We're just using coloured rectangles. I guess there also needs to be a basic game loop, where you can do some very simple things, like having a title screen, and then the ability to play the game until you die or run out of levels or whatever finishes the game. Some of this effort has been done by past me in my previous Agon videos. It's almost like I was planning this from the start. I wasn't, and I did say almost. This is how I work. I do something, then I work out what should come next, kind of logically. There is no real plan. So it's about time for some actual real programming. So let's see what I've got working. Okay, so this is the editor that I use for all my coding. I did use Visual Studio Code for a bit, but then I accidentally opened up Kate, which is the KDE's default editor, and I found actually it does everything I want and doesn't do all the annoying pop-up rubbish that Visual Studio does. So I may as well stick with this. It's got a terminal at the bottom that I can turn on and off. The syntax highlighting looks fairly decent, and I can access all the files down the side, and it's got Git, so this'll do. It's quite nice actually. So what I've got here is, this is all the source in all the various folders and everything. And then everything is driven using this makefile. So the main thing to do in this makefile is just change the name, because that's what creates all the binary and everything, and then you need to maybe fill in the description. If you've got things in different places, like this is where my SD card is mounted on this machine, this is where the emulator lives, this is where the sprite editor that I use lives, because I use the Steam version, and you need to change that. This bit, sort of ignore it, I'm fiddling around with this, and then down here is lots of cryptic, look at this, this is make files for you. This is just, yeah, this is what makes it all work, it's awful. But the end result is that if I go into terminal and I type make emulate, it appears just like that. So then I can do whatever I'm doing, and then that's it. And when I've done that, I just shut that off. I can go back into the code, I can change something, and then I just run it again. And there you go, it's changed. It's got that really quick turnaround, which is something that I need when I'm coding. I don't want to spend ages with memory cards and swapping things into real pieces of hardware. If I do that, I'm going to stop. So this is really, really easy to use. Right, so if I run the game again, this is as far as I've got. It doesn't look that great, but this is like the beginning point. You've got to start somewhere, and you're not going to waste hours of your life making a very fancy title screen and very fancy game if you don't quite know what you're doing. Ignore any weird flickering that you see in the emulator. That's probably a combination of just the emulator, my very weird Linux setup that seems to have weird graphical glitches in it anyway, and then also I'm video capturing it using OBS. Well, here's me. Woo, hello. So we have a basic title screen, and then I can start what is going to become the game. There's 3 sprites here, each one is different, that's why it's a different colour. And they're animating, which shows that I'm switching images as well to simulate some sort of animation. And because there's more than one sprite, that requires considerable more effort for both me and the machine than just having a single rectangle on the screen. Because now it's got to track each one. One of them I can move with the arrow keys. And you'll notice that as I move it, the little stupid pointy arrow points in the direction that it's moving. So again, this shows that the code behind all this, I could just switch this out with some decent graphics, and I've got like the beginnings of a character that can move, and other characters that at some point we'll be able to interact with. So yeah, I know it looks a bit crap, and like you could have made this in 10 minutes, but that's because I did make it in 10 minutes. Once I'd written all the code behind it. So let's go look at some of that code to understand how this is working. So what you're looking at on the screen at the moment is the code that drives that screen where we were playing the game a second ago. I won't go through every single piece of code, but I'll go through like the general gist of what's happening. There's several functions which, if you've ever written anything in any form of game engine before, is kind of standard, I guess. There's an init function that happens once when this screen is created. There's an update function where you do all your game updates. And then there's a drawing function where everything that appears on the screen gets drawn, or you do something that causes things to appear on the screen. Everything works like this, so I nicked the idea as well. In the init function, we're setting the screen mode, we're loading in the various sprites for the different players, and I'll show you what that is in a minute. We're then instantiating a player and 2 different enemies, and I'm saying where on the screen they go. In the update function, all I'm showing is that if I press the X button, that simulates like the game ending, just to test whether I can go back to the menu screen. I'm then doing some really shonky vector maths, sort of, that if I press up, down, left or right, it moves the player, and then updates the sprite system. This return function from inside my update loop controls which screen I go to next time this is running. This is all being run through a little state machine that I'll show you in a second. -1 just means you're coming back to this screen the next tick of the game loop. The number otherwise represents the screen to go to. Here's some hideous maths to work out which way the sprite is pointing, just so I can change which graphics appear on the screen. Here's the code for the title screen. Again, it's got an init function, an update function and a draw function. The init function just loads the bitmap, which is the title screen picture, and crashes if it can't, because I don't quite know what to do if you can't load an asset. You may as well just crash. And then In the draw function, we're clearing the screen, we're drawing the logo, we're printing some text, and that's all we're doing. If you press the Z button, which I've decided is going to be the fire button, you're going to go to screen number 2, which is the game. So now let's look at how all this is wired together, because at the moment these feel a bit disconnected from each other. Something somewhere must be controlling which of these screens appears. And all that is handled from the main function. So here's good old main.c. What I do in this is I first have to initialize various bits of the hardware, and then I initialize my sprite system that I've got. And we won't go into that today because I'm still building it and I'm still changing it whilst I'm trying to write this game. I load a font, and then this bit here is where I define what each screen is. The first screen is always an error screen, which is screen number 0, and then screen 1 is the title screen, and screen 2 is the game screen. So if you look in the title screen, if you press the Z key, you go into screen number 2. So 0, 1, 2. So we're going to go to the game screen. In the game screen, if you die and it's game over, you're going back to screen number 1, which is the title screen. And I then set the current screen. If I set the current screen to 0, you'll see the error screen that I've got. There we go. This garbage is where there's supposed to be an error message that I've not supplied because I'm just kind of forcing this screen to appear. I've built a sort of blue screen of death type thing into my game engine. I need some way of displaying error messages to tell me what's gone wrong. I can't just use printf, because if you look at the size of the text, if I run it again, this is done in the Agon's text mode, so it can show quite decent high-res text. You can get like 80 column text in this and it looks quite good. But in the resolution that I'm running the game at, this press fire text is an 8x8 pixel font, so I can't print much text, and if I print it on top of the game, I can't see the game. So I need somewhere to put it. There is a way of printing out the Agon's USB port, but the emulator doesn't support that yet, so I can't rely on it, and I don't want to use real hardware all the time. So I've made a screen to crash to that can show me some text, so I at least understand where something has crashed, which is half the problem of finding out code that doesn't work. So here's how the screen switching works. There's this function here called run screens, and that is part of this screen state machine that I've built, which is quite complicated. If you've never seen a state machine before, maybe I'll do a video about it one day, but for now just go Google what a state machine is. They're quite clever, but you can sort of get a bit confused and messed up with them. They can get very complicated very quickly if you try and make them do too much. All this does is, in this run screens function, we just work out what the current screen is. We then call its update function, and we call its draw function. And if the update function returns a number that isn't -1, it then loads that as the next screen to draw. And there's a lot of extra code just to stop it crashing if I try and switch to a screen that doesn't exist. There's a bit of code down here to change the screen mode so that I didn't have to keep typing out these lines of code all the time. Also, because this is C and not C++, this is how we do objects in C. It's a struct with function pointers inside it. So you can imagine that's a class. If you've not done C before and you've done C++, it's the same sort of idea. I think early versions of C++ used to do this behind the scenes before they had proper objects. So that's how the screens work. What I'll show you now is kind of how I get the graphics into the game. Because it's one thing showing you like, look, this is something called player.spr. But what is an SPR file? And if I go into the title screen, we load in game title.222. What's that? So I'll show you that bit of code next. Right, so to get graphics in the game, I'm using a sprite editor that I really don't know how to pronounce. This one. Sprite? I don't know. I wish they'd explain it, but anyway, it's over on my second screen. Let's bring it in. I like this program, partly because it just draws sprites and it doesn't try to be Photoshop, but also it's got that sort of cool old school style hand created GUI about it. if I ever do a GUI for anything, I want to make it look like this. I just like this style of thing. It reminds me of the stuff on my ST before everything became standardized. Although I'm using Linux and nothing's standardized on that, is it really? I've got KDE, GNOME and this thing all mixed together. But if I open up an image, we will pick the player. Here we go. Look at this. This is like my art style. This is fantastic. I'm not a graphics designer. I'm not an artist. I also have loaded the wrong thing. That's just the PNG. We need to actually open the... Oh, right, this is better. This is what I was trying to show you. So I've got different frames down here. And as you just saw a minute ago, they all get turned into just a sprite sheet, which is just 16 by 16 blocks all stuck together. This bit down here is where I'm sort of abusing how this sprite editor's system works. You can tag frames and give them a name. So I've tagged them as up, down, left, right, up, left, up, down, etc., dead, pointing, shooting, etc. And what I can do is use this now in my code, because when I export this, let me drive the software properly. Export sprite sheet. Here we go. So when you export this, you export the PNG, which looks like this, but you can also export a JSON file. And if we go look at that, so here's a JSON file. What this has got inside is each frame, it tells you the coordinates of where it is in the sprite sheet, and then a bunch of other junk, and the duration for the animation. All I make use of is where in the sprite sheet it is, and the duration. And it's got one for every single one. At the bottom is this extra bit, and it's got the name of the image that it's loaded from. I make use of that. And then it's got these tags here, and it tells me from which frame to the other frame each tag applies to. So we've got up, right down, and etc. whatever, this bit here. I have a Python program that reads this in. So if I load that up, I can show you how that works. This is my code that generates sprites. A sprite to me in my game engine has weird names that I've not quite decided what to call things. I need to fix that. Everything in my head is called a sprite. The picture is a sprite, the thing on the screen is a sprite. I got the word sprite too many times in this. I need to sit down and plan it properly. But what this little tool does is it converts one of these sprite JSON files and the sprite sheet into a thing that I call a sprite, which inside the folder of what goes onto the SD card is this single file, which I can't show you the hex of because I don't have a hex viewer. But there's a load of images packed in here that is generated from this. And all I do is I take the image, I turn it into one of those RGB 222 format images from my previous video, which you should go and watch. I'll stick a link at the end somewhere. And it just glues a lot of images together, along with some data about where these images are, and then all the frame information. So that then inside my sprite code, which I've got here, I can read this in. And because I wrote this data file, I can write the reader code to be really easy. So it reads in the data and it puts it into structures so that I can get at the different frames and the different widths and heights of the sprites and define animation. And then in my sprite system, I don't actually have to do much coding when I'm trying to write a game. It's all done for me by code that I wrote previously. Now, because I'm all for automating stuff, I don't want to keep loading this and having to click File, having to click Export and Export Sprite Sheet and click on all these buttons, because I'm likely to do it wrong. I might forget to change Player to something else. Or like you saw before, I clicked on this and I clicked on Export, and I clicked Export As, and I've got the wrong thing up, and this is just lots of mouse clicking that annoys me. I discovered that I can automate all of that inside the Makefile. If we scroll past the scary bit, back up here. So, I know where the binary is. By the way, if you're on Linux, this is where Steam now stores all your games. And they're just there and you can run them, and it runs Steam in the background to connect itself up and everything. This is one of my most played Steam games. I've got like 100 hours or something logged on this. Let's see if Steam is open. Okay, here's my games. I've played this sprite editor for 301.4 hours. That is more than the 6 hours of Fallout 4 I'm currently playing, and the 12 hours of Stardew Valley. How long have I played Godot for? 4 minutes. I clearly loaded that just to see if it works. So yeah, I've played quite a lot of this. Mostly though it runs in the background and I forget to shut it and just Steam sort of ticks up all the time. Anyway, enough of staying on my Steam library. Go away. So I discovered anyway that there is a command that you can run. This bit here. Where you can make it do what I've just done, all the clicking of the mouse by itself. And then it will save the PNG file and the JSON file for you. So I can do this as part of my make file, so that when I hit make whatever, it does it for me. And that just saves so much time. It's all automated. This is how you should develop stuff. Spend a bit of time automating things so that you don't have to repeatedly click on all the buttons. That Python program that I've just closed, if I load it back up, there's a lot of Python in here. And I didn't spend that long writing it, because I actually sort of chat GPT'd quite a bit. Like when I'm at work and the kids are coding and they suddenly make something that's amazing, I first have to look at it really critically to work out whether they actually wrote it. So here I'm using a lambda function to do something, and somehow this quantizes an image down to 64 colours. ChatGPT wrote this for me and it works, I'm happy. If I saw that from a kid, I'd be like, what does lambda mean? And why are you multiplying 85 by itself inside a comment? Is that a comment or what's that mean, kid? And they're like, oh, I don't really know what any of this stuff means. I'm like, well, that means integer division. Why are you multiplying it by 85? And if they can't explain it, they've obviously ChatGPT'd it. But I did that, and all this stuff as well has been generated for me. So yeah, AI is one of those things that people are a little bit they don't like it very much because it's a bit garbage. It does have its uses. Some of them uses can be saving you figuring stuff out. If you know what you want to do, you just can't remember quite how to do it, and you don't want to go and ask somewhere else like Stack Overflow and have to wait for someone to appear to tell you that your question was answered 6 years ago and you should have gone and found that post in their search engine. So this is often quicker, but you do need to critically look at the code to see if it even works. Because some of the stuff that this has made has been complete garbage that hasn't worked in the slightest, and I've actually had to go and learn it and rewrite it myself. So obviously at the moment this game looks like complete hot garbage, and it's not just that I can't draw images and stuff. It does, I know it looks a bit shit, but this is like the first part. So I will have at some point a title screen on here. I don't know what the game is going to be called. If you've got some ideas about what the game can be, please drop it in the comments, because otherwise I'm going to end up ChatGPTing like half the game's story and it'll just come out as this complete nonsense. Because this is so basic and it's so undistracting, it means I can actually start thinking about how this character should move. Like at the moment, there's no inertia, nothing like feels that good. It's weirdly satisfying though, the fact that when I move, I can see which direction it should be moving in and it matches the direction it's moving. Even though it's nothing more than just the arrow changes direction, it seems to add a bit of depth to an otherwise very turd game. Another thing this lets me do is judge scale, like how big should stuff be in this game? How fast should it move? And I can very easily now play with stuff and get like the controls of the player a bit more tuned. Like I might want to do some inertia on this. If it's going to be an arena shootery type game, the character needs to be quite responsive so that they can move out the way. They might need to dodge things. But also I don't want it to be really slippy. I don't like it in Mario where he's got too much inertia. He runs really accurately like a fat plumber that's going to take some time to stop. But it does mean that you end up skidding off the edge of things if you can't counter that. And I'm not very good at that kind of gameplay. I want to make a game that I enjoy playing, because then I'm going to put more effort into making it fun. That's why I don't want to just knock out a Tetris or some other rubbish like that, because I'll get bored and I'll just be like copying something without really any feeling for it. Sorry, I was really distracted by being able to move a thing around a screen then. This is what I mean. If you start playing with the thing, you can start figuring out what's fun. and I might decide I want some sort of puzzle element to this. So maybe the player doesn't need to move this quick, because if you're fast moving but it's a puzzle game, it gives the wrong impression of what the game is supposed to be. So let's slow that down to like 2. See, 2 feels a bit more sedate. Means you're not going to be quickly running out the way, so we're not making a bullet hell shooter with this style of movement. Now at the moment, this motion isn't doing anything clever. If I find sprite move, which is inside the sprite engine, we call this thing that looks quite fancy physics move, which is in this physics thing that I've invented. It's great, look at that, there we go. We add the position and the offset together and return it, that's all it does. And if we look inside what a point is, it's just an integer. So at the moment I can only move whole integers. So at some point speed 1 might be too fast, speed 2 might be too fast, and I'd like half would be a value that I'd want. So I'm going to have to start doing fixed point maths. I've got a bit of a beginning going here, but I've not yet implemented it. That'll be the next video, where I'll work out how to make fixed point maths work, and then add some like collision detection and stuff like that. So there we go, this is how the code works at the moment, and my next step, I think I've got a to-do list actually. Here we go. So this is my to-do list. I've drawn the sprites on the screen, I've got these things, I've got a basic game loop, I can move the player with a keyboard, I've done all this stuff, this is some basic housekeeping things that I need to do. But the sprites need a concept of physics or collisions. I need to do something. Like, at the moment, this isn't a game, this is just moving shapes. And as distracting as it is, these two things need to interact with each other. I shouldn't be able to just like drive over or underneath it. So we're going to look at some really basic axis aligned bounding box collisions, some fixed point maths. I need the enemies to move, so I need a way of programming them to do something. I've got multiple enemies, but they need to move differently. I want to do some shooting, because once I've got enemies and I can shoot them, it starts to feel more interactive like a game. So I'm going to go away and do that, and then that'll be part of the next video. If you got this far and you're still watching, I'm hoping you want to see the next video. If so, consider hitting the subscribe button. Also, if you have the means, it'd be amazing if you supported the channel by following the link that's in the description. Completely optional. You watching this video is all I ask really. Thank you very much. So now I've got a working game loop, a player that moves around the screen, and some enemies. Doesn't look like much, but behind the scenes we've got a lot of core functionality that's been implemented. Next time I'll be making the enemies move, and we should get some basic collision detection working, so I can shoot at stuff. I find once you get that bit working, it feels like a game and it actually becomes sort of fun to play. Now if you're wondering why there was such a massive gap between this video and my previous one, well, my PC died and I had to endure a massive farce getting it replaced. The story of this is on my second channel, which I've linked at the end of this video. Shouldn't really take over a month to buy and build a computer, should it? And yet somehow it did. If you're still watching, you're exactly the kind of person I'm making this video for. And I could do with your assistance. You see, I'll figure out how to write the code for whatever this is myself, and I quite like the idea of designing it. That bit's different and creative. However, my imagination is not that good. So in the comments below, drop some ideas for what you think the game could be about. Where might it be set? What might the player be trying to do? What might the story be? You see, I could go and ask ChatGPT to do that, but it just comes up with complete garbage. So, you know, give me some ideas, that'd be really nice. And until then, I'll see you next time.